Properties of colloidal solution. The first one is colligative property. Colligative properties are of four types. One is relative lowering vapor pressure, osmotic pressure, elevation in boiling point, and then depression in freezing point. We are going to just study one of the example of it. Elevation in boiling point. Elevation is nothing but increase in boiling point. Boiling point is nothing but when vapor pressure is equal to the atmospheric pressure, that point is called as boiling point. Actually, what happens here? If it is only a water, here the hydrogen bonds are broken and that liquid water is converted to gaseous state. That liquid water vapor wants to go up in the atmosphere, but the atmospheric pressure is very large. When this vapor pressure is equal to the atmospheric pressure, then that vapor will go out in the atmosphere. To the solvent, now we have added the non-volatile solutes. What is happening? All these molecules are adsorbed on the surface. The vapor which wants to go up, suppose we have taken water, that water will boil at 100 degrees centigrade. But if that vapor wants to go up, more temperature is required because we require more pressure, so that these molecules will allow this vapor to go out in the atmosphere. So there is increase in boiling point of that solvent. But we have taken the true solution here. But if we have taken the colligative solution, if we have taken the colloidal solution, here what happens is the particles are aggregating. As particles are aggregating, we are getting only few particles in the solution. So what happens here is bigger aggregation of colloidal particles make the colligative property value in smaller order compared to true solution. Let us study the next one. Tyndall effect. We shall study the next property. To study this Tyndall effect, we are going to illustrate few examples. Let us take a beaker. In this beaker, I have taken true solution. Suppose salt and water I have taken. So this is homogeneous mixture. In both the container, we have taken true solution. This true solution we are going to observe with the help of torch. If I insert light in this solution and observe it at the direction of the light, what I can observe is a clear solution. If to the same solution, that is true solution, if I allow the light to pass and observe it at a right angle, I can see darkness in it. We are still going to illustrate this. If I take a container and in this, if I put colloidal sole, you can take a gum solution, gum and water. In one more container, I am going to take again the same substance, say the sole of gum, so colloidal sole, and observe this at the direction of the light. Here we can pass transmitted light. If I pass transmitted light through this and observe this at the side of this direction of the light, what I can see is opulence. Opulence is nothing but it is not clear. To the same solution, if I observe it at right angle, light is allowed to pass, transmitted light only, and observe at the right angle to the light passed through this, what I can see, the path of the light passed in this appears blue. Why it is appearing blue and whereas the true solution is showing the dark color? It appears blue because the colloidal particles are scattering the light. So, Tyndall effect is nothing but scattering of light. By colloidal particles. We can study application of this. Application, you can illustrate same thing. It can be used to differentiate between the colloidal soul and the true solution. This is having also two conditions. The first condition of Tyndall effect is the diameter of the colloidal particle must not be very small compared to the wavelength of light. Compared to the wavelength of light. So one more property is compared to the wavelength of light. पूरा भरी दो। The diameter of the colloidal particle must not be very smaller than the wavelength of light. One more is there must be large difference between the dispersion phase and dispersion medium's refractive indices. After studying these two properties, we are going to move on to the next one. It is Zsigmondy. After the chemist Tyndall studied the effect of Tyndall, now Zsigmondy wanted to study it. So he has taken an ultra microscope. He took ultra microscope and observed the colloidal particles through the right angle. He kept the colloidal particles in a glass vessel, and what he observed is he saw these colloidal particles shining like a star at the black background. So Zsigmondy, with the help of ultramicroscope. Observe the colloidal particles. Tyndall effect. And saw the particles shine like a star at dark background. After him, but there is some limitation of Zsigmondy. Zsigmondy could not describe the size and shape of these colloidal particles. So, limitation. He failed to explain the size and shape of colloidal particle. After these three, we are going to move on to the next property called as Brownian moment. What happens here is there is continuous bombardment of colloidal particles from the dispersion medium. Because of this, the solution is getting stirred, and due to this stirring, the particles are moving in zigzag motion. So, bombardment of molecules from dispersion medium particles acquire zigzag motion. This depends on two things. One is viscosity, another one is size. If size is smaller and viscosity is lesser, then the movements will move faster. So these particles are always in a zigzag motion. They will move in any direction. So movement of particles in a zigzag motion is called as Brownian movement. After that, we shall move to the coloring property of these colloidal particles. To observe this coloring property of colloidal particles, let us illustrate. We will take one container. In this container, we will add milk and water. Same container we shall take here. Milk and water again here. But here we are going to reflect a light called as a reflected light, and here we are going to pass the light called as transmitted light. These two lights are having different wavelength. If we observe these two solutions, what we can see is this solution looks blue in color, whereas the light transmitted light shows a red color soul. So why it is so? Because of the wavelength of the light. So property what we can write is the color property of colloidal particles. The color particle of colloidal solution is due to wavelength of light. Let us illustrate one more thing. I take one container. In this, gold soul is taken. Suppose this gold soul is having fine particles, very fine particles of gold soul. One more container we shall take. In this, gold soul is only kept, only the thing, the particles are little coarse in shape. Now we know colloidal size is about 1 nanometer to 2000 nanometer. So this is finest and this is large in size. This is also gold soul with large particle. What happens here is this fine particle soul appears red in color, whereas this appears purple in color. So from this, the property what we understand is the color property of colloidal soul depends upon the size of particle. After studying these, we shall move on to the next property called as charge on colloidal particles. This colloidal soul is having some charge. All the souls are having same kind of charge. The charge is due to the electrolyte ion adsorbed on that. Now let us take one example. Suppose